Hi, my name is Syahirah Binti Abdullah. In this video, I will present about my project for Electrical Power Technology subject. The title of this project is Three-Phase System with Y-Connected Generator. So, let's start with the introduction. The three-phase system is used to generate, transmit, and distribute electrical power. It generates power on a large scale to meet the need of industry and commercial establishment. Three identical single-phase transformers are connected suitably or combined on a single core to form a three-phase system. Based on various types of industrial need, the step-up and step-down transformers are employed for generating, transmission, and distributing the electrical power. The building of a three-phase transformer unit is economical as it consumes less material compared to connecting three individual single-phase transformers. Additionally, the three-phase system transfers AC power instead of DC and is simple to construct. As known, a single-phase transformer is a device that is capable of transferring electrical energy from one circuit to one or more circuits based on concept of mutual induction. It compares two coils, a primary and a secondary coil, which help to transform the energy. The primary coil is connected to a single-phase supply, while the secondary is connected to a load. Similarly, a three-phase transformer consists of a three primary coil and three secondary coil and is represented as three-phase. A three-phase system can be constructed using three individual identical single-phase transformers, such as a three-phase transformer is known as the bank of three transformers. On the other hand, the three-phase transformer can be built on a single core. The winding of a transformer can be connected in either delta or Y configuration. The following paragraph describes three-phase transformer which utilize the delta and Y connection. First, delta to delta connection. Second, Y to Y connection. Third, delta to Y connection. Fourth, Y to delta connection. Next part of this article, we will discuss about three-phase transformer using the open delta and open Y connection, where one of the single-phase transformer making up the three-phase bank is omitted. Initially, we explored the idea of three-phase power system by connecting three voltage sources together in what is commonly known as the Y or star configuration. This configuration of voltage sources is characterized by a common connection point joining one side of each source. Three-phase Y connection has three voltage sources connected to a common point. If we draw a circuit showing each voltage source to be a coil of wire, alternator or transformer winding, and do some slight rearranging, the Y configuration becomes more obvious. Three-phase four-wire Y connection use a common forward wire. Three conductors leading away from the voltage sources winding toward a load are typically called line, while the winding themselves are typically called phase. In a Y-connected system, there may or may not be a natural wire attached at the junction point in the middle, although it certainly helps potential problems should one element of a three-phase load fail open, as discussed earlier. Three-phase three-wire Y connection does not use the natural wire. When measured voltage and current in three-phase system need to be specific as to where measured. Line voltage refers to the amount of voltage measured between any two line conductor in a balanced three-phase system. The line voltage is roughly 208 volt. Phase voltage refers to voltage measured across any one component, source winding or load impedance. In a balanced three-phase source or load, the phase voltage is 120 volts. The term line is current and phase current follow the same. Logic: the former referring to the current through any one line conductor and the latter to the current through any one component. Y-connected sources and load always have line voltage greater than phase voltage and line current equal to phase current. If the Y-connected source or load is balanced, the line voltage will be equal to the phase voltage times the square root of 3. However, the Y configuration is not the only valid one for connecting three-phase voltage source or load elements together. First, evaluate the parameter of the electrical system in the context of transmission and load impedance, current, voltage, and acceptable voltage drop based on BS 7671 or any Malaysia authority standard. Second, to understand the significance of the phase sequence for the generate voltage of a three-phase Y-connected generator. Third, evaluate and analyze the active power absorbed by the load by using 2 wattmeter method and the conventional measuring method. Justify the normal operating condition of the electrical system and validate the study with simulation. First step, problem. Analyze active power absorbed by the load. Second step, research background on three-phase system star connection. Third step, draw circuit of three-phase Y-connected generator using PSIM software. Fourth step, test the circuit by running a simulation on PSIM software. Fifth step, did a calculation to get the value of power at load, voltage, and current. So the last step is when values show the same result, the simulation considers success. For the result, we have to find phase voltage primary, phase voltage secondary, line voltage to natural primary, line voltage to natural secondary. So we have to get voltage 1 until voltage 12. So all the value we can get from the graph. The value rate line voltage of generator that was given to me is 132 kV based on my matrix number 191092342. My value for transmission loss is 42 plus 23 J ohm and the value for the load is 91 plus 9 J ohm. To calculate the value of inductance, I use the formula XL equal 2 pi FL. Then we can get the L value. To find the current at the load, I line equal to E phase divided by Z total. Since I line equal to I phase, then we can find the voltage at the load, which is V phase equal to I phase multiplied by load. For voltage drop percentage, voltage supply minus voltage load divided by voltage load and multiply with 100. To calculate each power at the load, almost similar formula that was used. Real power formula is 3 multiplied by V phase, I phase and cos theta. Reactive power formula is 3 multiplied by V phase, I phase, sin theta. Lastly, apparent power is 3 multiplied by V phase, I phase. To find load power factor, it is equal to cos theta. Calculation using 2 wattmeter method is shown in this slide is using the similar formula, but for reversing polarity, the phase angle has to be at by 180 degree phase angle to find the P total and P1 plus P2. Each phase are having a phase difference of 120 degree, i.e. 120 degree angle electrically. So, from the total of 360 degree, 3 phases are equally divided into 120 degree each. The power in 3-phase system is continuous as all the 3 phases are involved in generating the total power. Evaluate and analyze the active power absorbed by the load by using 2 wattmeter method and the conventional measuring method. The sinusoidal wave for 3-phase system, the size or metal quantity of a 3-phase device is not having much difference. Now, if we consider the transformer, it will be almost same size for both single phase and 3-phase because transformer will make only the leakage of flux. So the 3-phase system will have higher efficiency compared to single phase because for the same or little difference in mass of transformer, 3-phase line will be out where in a single phase it will be only one, and losses will be minimum in 3-phase circuit. So, overall, in conclusion, the 3-phase system will be better and higher efficiency compared to the single-phase system. Justify normal operating condition of the electrical system and validate the study with simulation. So the last part is conclusion. As a conclusion, I have known how to evaluate electrical system parameters. It can be found on the circuit which I draw using PSIM software and calculation base. Then know how to evaluate and analyze the power absorbed by the load by using 2 wattmeter method. And the conventional measuring method, I know how to determine and measure the active power consumed by the load. Mastering the program and estimation is really critical here. Moreover, to determine the phase sequence of 3-phase supply and also manage to identify the waveform and determine the relationship between line and phase voltage as well as current for Y.